Hi, my name is Nitsan Gadish and I'm an Applications Engineer in Analog Devices MEMS and Sensor Technology Division. I'm here to talk today about the ADXL362, which is a breakthrough low-power MEMS accelerometer that consumes at a typical supply voltage of 2 volts, less than 3 microamps throughout its full range of output data rates up to 400 Hertz. In addition to being low power on a device level, the 362 also includes a bunch of system-level power savings features. One of these features is the patent-pending awake status output. The awake status output basically indicates the motion status of the device. When the device is moving, the output goes high. When the device is not moving or stationary, the output goes low. Accelerometers are commonly used in applications that require some sort of motion activation, and here's how that's normally done. So an accelerometer is incorporated into a system and communicates with the processor via a digital protocol and interrupts. The accelerometer is configured to generate an interrupt when an activity is detected or an inactivity is detected, and the system processor responds by managing power to the rest of the system. The issue here is that even when the system should be off, it's still consuming standby current. And in a system that has multiple components and where power reduction is absolutely critical, standby current can be significant. This is where the awake status of the XL362 is extremely useful. So with 362, we can map the awake status to one of the interrupt pins, and we end up with an output pin that indicates the activity status of the system. We can connect that pin to the gate of a switch and then connect power to a system via that switch. And now what we've done is we've created an autonomous motion switch that can manage whether system power is on or off without requiring the intervention of the processor. So here, when the accelerometer is in motion, it closes the switch and the system operates normally. And when the accelerometer is stationary, it opens the switch and disconnects system power. So when we want the system to be off, it's really off. It doesn't use any standby current. In this configuration, the accelerometer can consume as little as 300 nanoamps in a motion-activated wake-up mode, so this makes the system extremely power efficient. So now that we've seen this in theory, I wanted to show you a real-life demo. What we did in the lab was we made a standalone motion switch board using the awake status output of the XL362. We put barrel plugs on it so that it can be plugged into the power path of essentially anything that consumes around 3 volts and about less than 1 or 2 microamps. So for example, I can save a lot of power in this battery-powered LED by making it motion activated. So I can plug that into the path, and now as long as I'm moving the accelerometer, the LED is on, and as soon as I put it down, the LED turns off. LED lights are cool and bright and all, but it's more interesting if you can see this work in a real-life application. For this video, we wanted to do something fun. So we went to the store and bought this bubble wand that initially had a button switch on it. So we replaced the button switch with the motion-activated switch. And now with motion, we can make bubbles. And you don't have to worry about remembering to turn them off. For more information on the ADXL362, please visit analog.com/ADXL362. Thanks for watching.